Hi everyone, we can learn how to simulate the Boolean functions or Boolean circuits using Cedar logic. Okay, so we can download this Cedar logic application. We can download this. Okay, download this first and install. Just double click and continue this operation, and finally install this Cedar logic simulator in your system. Then we will get an icon like this. Just open it. Here we have this window for creating. This is the editing area or workspace. We can create various circuit over here, and here we have various basic gates. Basic gates are available: 2 input AND gate, 3 input AND gate, and all possible different varieties of gates are available here. Similarly, we have this NOT gates. We have different types of varieties of input options and output options. We can use this particular input, and this one we can use this LED for showing our output values. And here we have this decoration option. Actually, this decoration option indicates this text field. Using this text field, we can mark various input and output. Okay, and multiplexer circuit, decoder, all these types of gates and other chips are available here. We can use if we need for our circuit. Okay, so consider one example. So using simple gate like this, we can use this AND gate. Just click over here and drag and drop in this workspace. Now here we have this AND gate, 2 input AND gate here. And now we can set this input and output portion. Okay, here it is at 2 input AND gate. So take this input here and connect with the one of this input side of AND gate. Take one more input and connect with the other leg of this AND gate. Okay, and for this output portion, we can simply connect an LED. Okay, so this is simply an AND gate with 2 input and an output. We can mark here using labels. For that, use this decoration option, and if you need to arrange this orientation for this text, simply right click over this text field. It will rotate 90 degree. Okay, so and for changing this size and all, double click over here and we can reduce the size or increase the size, and we can label. Suppose we can label for the first input as A. Okay, now we can take one more input, double click, reduce the size, or we can increase. Here we can increase the size of our text by adding value 3, 4, etc. Okay, so now we can mark here as B. So first input we can call it as A, second input of this AND gate as B. And if we need to mark for this output, we can add this text field again for this output and double click, reduce the size or increase the size using value 3, 4, etc. And we can mark this as output Y. Okay, so now this is the input and output part of our 2 input AND gate. Now we know that the output of AND gate become 1 only if both A and B input equal to 1. Okay, if both are equal to, both input equal to 0 or any one of the input equal to 0, and then these 3 cases the output is always 0. Okay, so output is here, it is actually an LED. So 0 means LED in off stage, 1 means LED in on stage. Suppose now this A and B both are in off, no input. Okay, so in this case output LED is in off stage as expected. Okay, suppose A is in on mode but other input B is in off stage. Again output is off as expected. Okay, now consider both A and B equal to 1. That means A input is applied, B input is applied. In this case, if both equal to 1, then output of AND is as expected, it is high here. Okay, suppose B is on and A is off, again output is 0. So this is the simulation of an AND gate. Okay, now we can consider any kind, or we can simulate any kind of Boolean circuit. Or if you want to delete, just click over that simple or input, output or gate and press the delete button. Okay, now consider one example. This is the case, and here we have this truth table, and after simplifying this output value, we get an expression C or A complement and B complement or A and B. After further simplification, we get, or here we have another expression which is equivalent to this expression, that is C or A XNOR B. Okay, so this is actually derived for this particular given truth table, right? Now we can implement this particular circuit. Okay, so consider this. The expression is C or A XNOR B. Or we can use this particular expression. Here we have one OR gate and one XNOR gate. If we are using this particular expression, we need two OR gates and complement inverters and gates also. Okay, so consider input. Here we need three different input C, A, B. Okay, C, A, B. So for three input A, B and C. Now we can mark, or we can put some label for this input. Here it is A. Okay, this one is A. Another this one is B. And this one is C. Okay, three input part. Now this one is A XNOR B. Okay, we need XNOR gate. So these gates, XNOR is available here in this basic gate option. Okay, under this basic gates, we have this two input XNOR gate. Okay, so just click over here, drag and drop in this workspace. Okay, then connect this A with one of the leg of this XNOR operator gate and this B with another leg of this XNOR gate, right? Okay, now we need to OR with C. So we need a two input OR gate. Okay, so this is the two input OR gate. One of this OR leg is connected with the output of this XNOR gate. The other one is connecting with the C input. Now this is the circuit corresponding to this C or A XNOR B. Okay, so we need to set an output LED to get the result. So put this LED here at the output part and connect the output line with this LED. Now we can check. Okay, so here for the combination 0, 0, 0 for the inputs, we are expecting an output 1. See this, here A is in off stage, means A equal to 0, B is 0, C is 0. In that case, a flow occurs through this particular portion and here we get an high value. That means the LED is in on stage now. That is why this red color. Okay, so this is the expected output. Consider other case, A is 0, B is 0, C is 1. A is 0, B is 0. Switch on this C input. Again, in this case, output is active stage. So that is why this LED is blinking. Okay, third case, A is 0, B is 1, C is 0. So switch off the C input and switch on this B. That is 0, 1, 0, 0, 1, 0. Here we expect an output 0, exactly like this. Here we have the output LED in its switch off state, which is equivalent to this output value 0 for this combination 0, 1, 0. Okay, next is input is 0, 1, 1. A0, B1, C1. A0, B1, C1. Okay, for this the expecting output is 1. That means the LED is in switch on stage now. Next case, 1, 0, 0. A is 1, B is 0, C is 0. A is 1, B is 0, C is 0. Okay, switch on this A, B 0, C 0. In this case, the expected output is 0. Exactly, here we get this output LED in its switch off mode. Okay, next is 1, 0, 1. A is 1, B is 0, C is 1. Okay, 1, 0, 1, expecting output is 1. Here again, the LED become switch on stage. LED is switch on now. Okay, next is 1, 1, 0. Here it is A is 1, B is 1 and switch off the C input. 1, 1, 0. Again, expected output is 1 here. Exactly. The output of the circuit is this particular LED of this output part. The circuit output is connected with this particular LED. So after setting this input 1, 1, 0, we get this LED in its switch on stage, which is exactly matching with the expected output 1. 1, 1, 1. A equal to 1, B equal to 1 and C equal to 1. Expecting output is 1. Check this. A equal to 1, B equal to 1, C equal to 1. Output is active stage. Output is an active stage. That means which is matching with the expected output 1. LED is in switch on stage now. Again consider A equal to 0, B equal to 0, C equal to 0. Output is in 1. Then 0, 1, 0, 0, 1, 0. Output become 0. So this is the Boolean circuit implementation or Boolean circuit simulation corresponding to the derived expression over here. Okay, which will exactly generate an output which is given over here in this truth table. Okay, so after understanding all this, we can implement various Boolean functions using all the possible input available over here. Instead of this basic gates, we have this inverters, decoders, multiplexers, flip-flops, registers, comparators, parallel adders, and all these kinds of inputs are directly available over here. We can make use all these kinds of inputs in order to implement various different Boolean expressions or for the simulation of various Boolean expressions. Okay, thank you.